Hello kids, welcome to ICSE Chemistry Hub. Today I'll be dealing with the grade 10 chapter of electrolysis. I know this will be a little difficult chapter for most of the grade 10 ICSE students. So this would be the first chapter and my first attempt on teaching this chapter. Hope you all like this. So as you are aware, this is one of the most important chapter of grade 10. And the name of the chapter is Electrolysis. You must have read this term in your lower classes. Now, as you can see, this word, electrolysis, comes from two different words. You have a word called as electro, and then you have got a word called as lysis. The word electro means nothing but electricity. And lysis, whenever we use the word lysis, it means to break something. So, putting the words together, the meaning of the word electrolysis is breaking a compound with the help of electricity. As you can see in the slide, the word electro means electricity. Whenever we speak about electricity, it is nothing but the flow of electron. And lysis means, in simple words, it means breaking something. Here it means pertaining to. So what is electrolysis basically, kids? It is nothing but breaking of a chemical compound. When we break a compound, it will result in nothing but it results in the formation of ions. So whenever we are carrying out electrolysis, it deals with the breaking of a chemical compound, and what will it result into? It will result in the formation of something called as ions. Now in your lower classes, you have learned what ions are. What are ions, children? Ions are nothing but they are charged particles. Now here what you can see is actually the definition of electrolysis. But before we go ahead with the definition of electrolysis, let us first understand the basic apparatus that is used for electrolysis. Whenever we need to break a compound using the process of electrolysis, this is a cell that we will be using. What is the name of this cell? We call it as an electrolytic cell, or there is one other term that is given to it. We call it as a voltameter. So what is the first apparatus that we will require whenever we do electrolysis? We need this apparatus. What is the name of this apparatus? This apparatus can either be called as an electrolytic cell or it can be called as a voltameter. Clear? Now whenever we are using a voltameter, can you all see this apparatus? This apparatus, the only condition that is required for making an electrolytic cell or voltameter is that it should be a non-conducting vessel. That means in itself, it should not happen that it should start conducting electricity. Okay. So the first thing that we require for carrying out electrolysis is this electrolytic cell. What's the other name for electrolytic cell? It's also called as a voltameter. Okay. And what will decide, on what factor will you decide whether you can use this particular electrolytic cell or not? Whatever vessel you're using, whatever voltameter you're using, it should be a non-conducting vessel. It should not be conducting electricity on its own. I hope I have made myself clear. So the first thing that we require is an electrolytic cell. What's the other name we use for it? We call it as a voltameter. Then can you see here, children? We have taken two batteries here. Whenever we do electrolysis, we require two metallic plates. Now, whenever we are dealing with a liquid, we will not use batteries here. Instead, we use two metallic plates here. One of the metallic plate will be called as a cathode, and the next metallic plate will be called as an anode. So, the second thing that we require are two metallic plates, which are called as cathode, and the other plate will be called as the anode. Now, what is the basic difference between a cathode and an anode? Please remember the word that I am giving you. You have to remember the word or the short form as PA. What does P stand for? The positive terminal is always called as the anode. Am I clear? So, what is an anode? The positive terminal of the battery is called as the anode. Or we can say, can you see here? It is connected to the positive terminal. So the metallic plate that is connected to the positive terminal will be called as the anode. And what is cathode? Cathode is connected. Can you have a look at which terminal is it attached to? it is attached to the negative terminal of the battery. So that whichever metallic plate is connected to the negative of the battery, we call it as the cathode. So what is the first thing that we will require, children? We require an electrolytic cell, or we call it as a voltmeter. The second thing that we require are two plates. One which is connected to the positive of the battery, whichever is connected to the positive of the battery, we call it as the anode. Clear? As you can see in this diagram, it is connected to the positive of the battery. And the other plate is connected to the negative terminal of the battery. The one that is connected to the negative terminal, we call it as the cathode. So always remember, anode is positively charged and cathode will be negatively charged. So this is the second thing that we require for electrolysis. What's the third thing we require, children? As you can see, electrolytic cell is done. We require a non-conducting vessel. That means in itself, it should not start conducting electricity. The third thing that we require is called as an electrolyte. Any substance, any compound on which I want to carry out the process of electrolysis will be called as an electrolyte. For example, if you can see in this diagram, can you see here the word electrolytic solution? Always remember, whenever we are doing electrolysis, there are only two states in which I can carry out electrolysis. I can never do electrolysis on a solid state compound. If I have to do electrolysis, it should either be in the molten state or it should be in the fused state. Clear? So whichever is the chemical compound into which I am planning to pass electricity, that will be called as my electrolytic solution, or I call it simply as the electrolyte solution. Please remember, whenever we are doing electrolysis, in which two states can I do my electrolysis process? Either the substance should be in the molten state, or what is the meaning of the word molten? Molten means it has to be melted, or it has to be in the fused state, or we call it has to be in the solution state. So I can do electrolysis only in two states. Either I call it as the molten state, or what is the other word I can use for molten? I have to use the word fused. Or I can carry out electrolysis only in the solution state. So if there is a question asked, for example, can I do electrolysis for solid NaCl? What would be your answer, children? Can I do electrolysis for solid NaCl? Never. I cannot use solid as an electrolyte. As I told you, whenever I am doing electrolysis, what are the two states I want it? Either it should be in the fused state, or what is the other word for fused? We use the word molten. Or it should be made in a solution state. That means it should be in an aqueous state. Have I made myself clear till here, children? Hope you're understanding it. If you're liking the channel, please do subscribe. So as I told you, for carrying out any electrolysis of any compound, these are the three basic things we require. We require an electrolytic cell, which is also called as a voltmeter. Second thing, we need a compound. It can be any compound into which I am planning to do my electrolysis. But the condition is, whichever compound I am selecting for electrolysis should be either be in the molten state or it has to be in the solution state. In solid state, I will never be able to do electrolysis. So this becomes my electrolytic solution, either in the molten state or in the solution state. Then I require two metallic plates, one which is connected to the negative terminal of the battery. The one that is connected to the negative terminal will be called as the cathode. The one that is attached to the positive terminal of the battery will be called as the anode. So now we will come back to our definition of electrolysis. So what is electrolysis, children? As you can see here, electrolysis, look at the first keyword that I am marking. It is the decomposition of a chemical compound. What do I mean by the word decomposition? Decomposition is nothing but, as the word indicates, I am breaking a compound. Now, whichever compound I have taken, that compound will be called as an electrolyte. In which two states? I just now told you which are the two states in which I can take the electrolyte. Either it should be in the aqueous state, or it should be in the fused state, or in the molten state. So come back to the definition. Electrolysis is the decomposition. This word is very, very important. Of a chemical compound. It can be any compound, but what is the chemical or the technical term for that chemical compound? We call them as an electrolyte. We know the electrolyte should be in an aqueous state or it should be in a molten state. And please do remember, whenever I'm carrying out electrolysis, I will always prefer DC current. What is the full form of DC? I will always use direct current. Okay, what would be the problem? You have got another type of current which is called as AC current. Clear? We call it as the alternative current. What would happen if I use alternating current? As you can see in this diagram, if I use alternating current, one time it will be positive, the other time it will become negative. So the signs will keep on changing. Cathode will become anode, anode will start becoming cathode. So whenever I am doing electrolysis, you should always remember that which type of current will I always prefer for electrolysis? It will be DC current or direct electric current. Have I made myself clear till here, children? So come back to the definition. We'll revise the definition once again. What is electrolysis? Electrolysis is the decomposition or it is the breaking of an electrolyte. What is an electrolyte? It can be any chemical compound, but that compound should compulsorily be either in aqueous state or fused state. And whenever I am passing electric current through it, it will always result. I will always use which type of current for it? I will always prefer direct electric current. Okay. Now, why am I doing the process of electrolysis? Can you see the last line that is written here? Whenever I am doing electrolysis, I am preferring to make discharge of ions. Now, what is the meaning of the word discharged? Dis means it should have no, and charge means it should have no charge. It should lose its charge. As I told you, whenever I'm doing electrolysis, children, it will always result in an aqueous solution. It will always result in the formation of ions. So whenever I'm doing electrolysis, what would be the next step? Ions are formed. Step number 1. Then the second step that will be resulting is, I want to make these ions lose their charge. That means it will result in the discharge. What's the meaning of the word discharge? Discharge means they should lose their charge. And as we know, when they lose their charge, they become, as you know, ions are nothing but charged particles. If they lose their charge, they become nothing but, they become neutral atoms. So once again, it is nothing but the decomposition of a chemical compound or an electrolyte, which two states? Fused, aqueous state. And it should be which type of current that we are preferring? We are using direct current. And it will result first, it will result in the formation of ions. The second step that should result is the ions should get discharged. They should lose their charge and then they should become neutral atoms. I hope this definition is clear to you. I just now gave you what an electrolytic cell is, what an electrolyte is. Now based on this, we have 3 types of electrolyte. We have a strong electrolyte from the word itself. What will be a strong electrolyte? It is any chemical compound which will allow large amounts of electricity to pass through it. What is a weak electrolyte? Any substance which will allow very, very little amount of electric current to flow through it. And how will we understand that it is allowing a large amount of current to flow through it? The bulb will glow brightly. If you are using a weak electrolyte, the bulb will be a little dim. And then you have some other substances called as weak non-electrolyte. What are non-electrolyte? Non-electrolyte, from the word itself, they will not allow electric current to pass through them. Clear? So basically they are non-conductors. So in this case, the bulb is not going to glow. Okay. Next, we are moving on to the difference between electrolyte and non-electrolyte. I just now told you what are electrolyte. Any substance, or can I say any chemical compound which allows large amount of electricity to pass through it. But when can I call it as an electrolyte? The electrolyte should be compulsorily be in two states. It should be either in fused state or in aqueous state. Clear? And what will be non-electrolyte? Any compound. The word itself, non-electrolyte. It will not allow electricity to pass through it in these two states. Which are the two states? Molten or in the aqueous state. Clear? And there will be no breaking of the compound happening in a non-electrolyte. Now, the major difference that you have to remember is mostly all ionic compounds are very, very good electrolytes. Now, what are ionic compounds? They are also called as electrovalent compounds. For example, the best example of an ionic compound is your sodium chloride. Instead of writing it as sodium chloride, can I write it as Na plus Cl minus? Yes, so this becomes nothing but an ionic compound. Can you see her, children? Though it is in the form of a compound, it already has some charges attached to it. Agreed, they are very, very strongly held by electrostatic forces of attraction. But they have these charged particles already present in them. So please remember this. Electrolytes are mostly ionic compounds. They are very, very good conductors of electricity. The moment I put it in water or the moment I melt it, it will start conducting electricity through it. Whereas all you must have learnt about these type of compounds. What are covalent compounds? A covalent compound is always found between two or more non-metals. So any covalent compound is an example of a non-electrolyte. Am I clear? So electrolytes are mostly ionic compounds. That means there should be a metal and a non-metal combination. Next, non-electrolyte, they are mostly which type of compounds, children? They are covalent compounds. Am I clear till here? The last point. If it is an electrolyte, there can be ions and there can be molecules. So as you know, whenever any substance is passing electric current through it, it will mostly result in the formation of ions. But in some cases, it can have molecules also. This we will discuss a little in detail in the next slide. Whereas non-electrolytes, as I told you, whenever there's a covalent compound, mostly it is made up of, we call it as hydrogen molecule, any non-metal, chlorine molecule, HCl molecule, NH3 molecule. So please remember, if they have ions, only then they will be able to conduct electric current through it. Whereas if they have molecules, please remember, molecules are not able to conduct electric current through it. Okay. So you can see here what are electrolytes. Electrolytes are nothing but any substance which will allow electricity to pass through it. All your strong acids. All your strong acids are nothing but electrolytes. All your strong alkalis. Now, what is an alkali? Alkali is nothing but a water-soluble base. What are alkalis, children? If the base is soluble in water, we call it as an alkali. As I told you, when can I call it as an electrolyte? Any solid substance cannot be called as an electrolyte. When can we call it as an electrolyte? When it is in either solid state, either in solution state, or it should be in molten state. So when that base is soluble in water, water-soluble bases will be called as an alkali. Whereas when you come to non-electrolyte, any covalent compound will be a non-electrolyte. For example, let us take glucose. Can you tell me what is the formula of glucose? It is C6H12O6. So this C6H12O6, can you see? This is a non-metal. This is a non-metal. Oxygen also is a non-metal. So can you tell me which type of bonding will be there? It will have covalent bonding. So the moment you hear it's a covalent bonding, you can be sure it is a non-electrolyte. When you come to, for example, let's take the case of Cu. Cu is 2 plus, SO4 is 2 minus. Can you see you have a metal here and here you have a non-metal. So basically which type of bonding would have happened in copper sulfate? It would be an ionic bond. And hence we know all ionic bonds are electrolyte, all covalent compounds are non-electrolytes. For example, I take alcohol. For example, this is an alcohol called as ethyl alcohol, C2, C non-metal, hydrogen non-metal, O non-metal, hydrogen non-metal. So again, this will have a covalent bond. So this will be again a non-electrolyte. Okay. Now we are going to learn the difference between strong electrolyte and weak electrolyte. What is a strong electrolyte? Any substance which will allow large amount of electricity, which will allow a huge amount of electricity to flow through them are called as strong electrolyte. Whereas electrolytes which allow very, very small amount of current to pass through them are called as weak electrolyte. Now please remember the major difference between a strong electrolyte and weak electrolyte. Strong, the moment I tell you it's a strong electrolyte, it is made up of, in the solution, you will be finding only and only ions. Whereas when you take a weak electrolyte, these are the things that are conducting electricity. Which one? Ions. But along with ions, you will also have some substances which are not able to conduct electric current through them. Okay, we call them as the molecules. So strong means it is made up of only and only ions. Whereas a weak electrolyte, it will have some ions, but mostly it will have molecules. So this is the difference between a strong electrolyte and a weak electrolyte. Now we are coming to the major difference. We are going to learn the difference between anode and cathode. In the diagram itself, I showed you what an anode is and what an cathode is. What is an anode? I had asked you to remember the word, the letter Pa. Any metallic plate, any plate which is connected to the positive of the battery. Can you see here? It is connected to the positive terminal of the battery. That is called as the anode. And the one that is connected to the negative terminal of the battery will be called as cathode. So the moment I start passing electric current through any substance, through any electrolyte, again my electrolyte should be in the molten state or it should be in the aqueous state. It will result, whenever it starts passing electricity, it will result in the formation of ions. Am I clear? Now please remember the words. Again, I am giving you two short forms. Please remember that. Remember the word A to A. And remember the word C to C. What are the two words you have to remember, children? There is one anode. What is the charge of an anode? Anode is positively charged. So can I write here? It is positively charged. I am putting the positive charge. Whereas here you can see that the cathode is negatively charged. That is what we have studied now. So when I am passing electric current through it, it will result in the formation of two ions. Which are the two ions that it will result in? I will get one negatively charged ion, which is called as an anion, and I will get one ion which is positively charged, which is called as the cations. All this you have learned in your lower classes, that whenever ions are nothing but charged particles. So any chemical compound that I take, when I pass electric current through it, it will result in the formation of ions. Clear? Now what are ions? We know there are two types of ion. One that is negatively charged and the other ion that is positively charged. The positively charged ion will be called as a cathode. Clear? Now always remember the short form that I have told you. A to A. What does this mean? A stands for anions. Anions are having what charge? Minus. Anions will go to anode. Am I clear? So what does A to A mean? A to A means anions will move to anode. And then you have to remember the next letter, C to C. Cations will always, what are cations? Cations are nothing but positively charged particles. They will move to cathode. So this is a short form that I am giving you to remember. This is a trick to remember it. What is the short form? A to A and C to C. So, or you remember it like this, that always opposites attract. Am I clear? So, if you have a friend who is of some other different nature, you feel a little attracted to him. In the same way is the case with electrolysis. Clear? So, anions, I just now told you, anode is having what charge, children? Anode is positively charged. And you have to remember A to A. So, anions, what are anions now? Anions are the negatively charged particle. Where will they start moving? Anions will start moving towards the anode. Am I clear? Anode is positively charged. Which ions will start coming towards it? The negatively charged particle will come towards it. Whereas the cathode is having what charge, children? I just now told you it is negatively charged. Opposites attract. Clear? So what is the short form you have to remember? C to C. Am I clear? So what does C mean? Cations, opposites. Cations are positively charged. So where will they start running towards? They will start running towards the cathode. So please remember the short form, anions, A to A, C to C. Positively charged anode will get attracted towards the anions. And the negatively charged cathode will start moving towards the cations will start getting attracted towards the cathode. I hope this concept is clear to you. So we'll deal with the last slide for today. As I've told you, what is anode? Anode is connected to the positive terminal, whereas cathode is connected to the negative terminal. And you have to remember opposites attract. Clear? So which ions will start moving towards the anode? Anions. What are anions? My anode is positively charged. So which particles will start coming towards it? The opposite charge. Whereas cations, they are negatively charged. So which ions will start getting attracted to it? Of course, the cations. Okay. Now you have to remember this, that why are these ions coming? These ions called as anions. Anions are what? They are negatively charged. What are cations, children? Cations are positively charged. Where will the anions go? A to A. The anions will start moving towards the anode. And what was the other short form that I gave you? C to C. What does C to C means? The cations will migrate towards the cathode. Am I clear? So, for now, this is the basic concept of electrolysis that I would like you to remember. Please do like and subscribe if you have understood the chapter till here. And please stay tuned for my next class, which would happen very soon. Till that time, keep revising, keep learning. Thank you.